Hello, boys and girls, and welcome to another episode of your favorite algorithm channel. My name is Ryan Powers, and today I'm going to be taking you through LeetCode 53 maximum subarray. So let's introduce the problem. Given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. Cool. Okay, so let's take a look at the input here. So this is our input, and we have values of -2, 1, -3, 4, -1, 2, 1, -5, and 4. And if we look at the explanation here, this is our largest subarray sum, which is going to output 6. And where is that? Well, that's right here. So what are we trying to do? Well, what we need to do is we need to traverse this array. And at each point, we need to keep track of what is the largest sum I've seen to this point. So as we're traversing through this array, we'll find that this subsection here is actually our largest subarray. So the goal here is to do this in one pass. We want to do this in n time, and that's what we're shooting for. So as always, I suggest that you try to solve this problem on your own first, and if you get stuck or you just want to see how I did it, then check out the video. Otherwise, if you're ready to get started, come with me to the whiteboard. We have our array from the example problem here. And we have two variables, our sum and our max. So we're going to be iterating through the array, and we're going to be tracking these numbers as we go. Well, this is the array from the example problem, so we know that our largest subsequence is this right here. And the value that we're going to get is 6. So 6 is going to be our answer. We know from the example problem that we need to return, or that our array is going to have at least one number in it, right? So we can just initialize this to be -2, which is just our first value. And we can start counting from this position right here. Well, what's the trick to this problem? Well, the trick to this problem is that we need to know whether we need to add to our current sum and updating our sum, or we need to restart our count, right? So what is the largest possible number we could make here at this position? Well, the largest possible number we can make at this position is the maximum value of the current number, which is the current number we're iterating over, and our sum plus our sum, or it's just the current number, right? So we want the maximum of this of these two values. So right here, if we evaluated this expression here, or this maximum function, well, our two values would be our current plus our sum, which would be -1, or our current value, which is 1, right? So we want to keep 1. So we'll update our sum to be 1, not adding it to our current sum. We're just restarting our count. So we'll iterate to the next value here, which is -3, and we'll ask the same question. So what would be current plus the sum? Well, that'd be -2. And what's just our current value is -3. Okay, well, -2 is larger than -3. So we'll put -2 here, and we'll do the same thing right here. So what's our current plus our sum? Well, our current plus our sum is 2. And just our current value is 4. Well, 4 is greater than 2, right? So we'll update this to 4, and we'll increment to our next value, which is -1. So our current plus our sum is going to be 3. And if we just took the current value, that'd be -1. Well, we want to keep 3 here, right? So we'll update this to 3, and we'll increment to our next value. So our current plus our sum here is 5. And if we just took our current value, that'd be 2. Okay, so we want to keep 5. So we'll update our sum to 5. And we'll increment to our next value, which is 1. Well, our current plus our sum is 6. And our current value is 1. So we'll keep 6. So we'll update to 6, and we'll increment to our next value, which is -5. So current plus our sum is going to be 1, and just the current number is going to be -5, right? So what we want to do is we want to keep 1. So we'll update our sum to 1, and we'll move on to our next value, which is 4. Our current plus our sum is 5, and just our current value is 4. So we'd want to keep 5. Okay, so we're done iterating through our array. We can see our answer here is 6. But what have we done? Well, we have basically tracked through our array, and we have just taken what is the largest possible value I can make at every single index of the array. So this is kind of dynamic programming of sorts, right? So we could say at every single index of this array, what's the largest possible sum, right? So this is the largest possible sum from the 0 index. This is the largest possible sum from the first index, and then so on and so forth, right? So from the 3rd, the 4th, the 5th, the 6th, the 7th, and the 8th index. This is the largest possible sum we could get at every single index. So what's left in this problem? Well, the only thing we need to do now is we just need to keep track of the max as we go, right? So if we initialize our max to be -2, which is our sum, then our max, so this is what our sum is equal to, and our max is going to be equal to the max of our current max and our current sum, right? So let's go ahead and just do a round of keeping track of both of these variables before we go ahead and solve this problem in code. All right, so we've initialized both of our values to -2, and we'll start here at -1. Well, we know that the maximum sum we can make between 1 and -2 is just 1, right? So now we need to evaluate our max. Well, the maximum between our current max and our current sum is going to be 1, so we'll update that to 1. And we'll move this on to -3. Well, what's the largest value we could make here? Well, that would be -2, right? So -2 and 1 is greater than, so -2 is greater than -3. Well, our max is still going to be 1. So we'll move on here. So what's the largest value we could make between these two? Well, that would be just keeping 4, restarting our count, right? So what's our max now? Well, the max of 4 and 1 is 4. So we'll move on to -1, which is going to be, okay, what's the max between 3 and -1? Well, that's 3. Our max is still going to be 4. So we'll move on here. The max now is going to either be 3 plus 2, which is 5, or just 2. Well, we'll take 5, and we'll update our max to 5. And we'll move on to 1 here. So it's either going to be 1 or 6. 6 is greater than 1. Our max is now 6. Then we move on to -5 here. Well, our maximum is either going to be 1 or -5. So it's 1. And our max is still going to be 6. And then we'll move on here to 4. Well, our maximum possible sum is either 5 or 4, so we'll take 5. And our maximum is still 6. So we end up with 6. So this is the whole problem. This is the whole problem. The trick here is just basically using dynamic programming to say what is the maximum possible sum I could make to this point, and then just using a variable, a maximum variable, to just track what's the current max that I've seen up to this point. So now that we understand the strategy for solving this problem, let's go ahead and see what it looks like in code. So inside of our max subarray function, the first thing we want to do is establish our two variables. So that's going to be our current sum, and we're going to initialize that to be the first item in the array. And then we want to do the same thing with our max. Okay, so then we want to loop over our array, and we'll just loop over letting I be equal to 1, right? Because we want to skip that first variable. We don't need to iterate over that again. Because we've already assigned that variable to be our current sum and our current max. And then we can say, well, I is less than the array length. Well, we can increment I. Okay, so at each iteration, what do we want to do? Well, we want to recalculate our sum. So our sum is going to be equal to the max. So the math.max of our sum plus our current value that we're iterating over, which is going to be the array I, and the array I. So it's going to be the max of these two values. And then what's going to be our max? Well, our max is just going to be equal to the math.max of our current max and our current sum. Okay. All we need to do is just return our max at the end. So not a whole lot to this code, but let's just go over it really quick just to do a recap of what we've done here. So we established our sum that we're going to track what's our largest sum, and we've established a max variable to track what our largest max is going to be at every iteration, we are recalculating our sum to be the maximum of the current sum plus the current number, or just the current number. So whatever the max is between these two values is what we want to keep as our sum, and then we want to update our max at every iteration to be the max of our current max and our current sum. So let's see, and then of course we want to return the max at the end. So let's see how we did. Okay, let's submit here. Okay, great. So now LeetCode's doing this new thing that's telling us how much memory we're using, which is another thing for you to obsess over. So we're using less than 18.85% of submissions for maximum Subarray. Okay, anyways, well, we can just quickly do time complexity and space analysis here. Well, what's the time complexity of this problem? Well, we already kind of talked about it. It's big O of n, right? We're doing one pass through this array. And then what's the space complexity? Well, we're not using any extra space here. So the space complexity we're only storing our variables, or we're only storing our information in our variables here, our sum and our max. So our space complexity is constant. Anyways, I hope you enjoyed this video. I hope you learned something, and I hope to see you in the next one.